So today's video is going to focus on our second learning target for the unit, which is based on Newton's second law, and we're really going to focus on how to manipulate the Newton's second law equation in order to solve for its components. The first thing I need you to do is take out your gold unit organizer and label slot 6 as Newton's second law notes in GP. And it'll be worth no score. The note sheet you were given that looks like this is going to be labeled number 6. And the first thing we're going to answer here is, what is Newton's second law? This is a quick reminder from note sheet number 4. Newton's second law states that force and acceleration have a direct relationship, while mass and acceleration have an indirect relationship. This means that as force increases, so if I push something harder or pull something harder, the acceleration of the object will also increase. But if the mass increases, it gets heavier, then the acceleration will decrease. So our Newton's second law triangle looks like this, where F is on top and M and A are next to each other. F is going to stand for force, and that unit is in newtons, which is equal to a kilogram times meters per second squared. M stands for mass, and that'll always be in the kilogram. So if you're ever given something in grams, you're going to have to convert to kilograms. And A stands for acceleration, and that'll always be in meters per second squared. So if we're trying to solve for force, we would cover up the F on the triangle, and we're left with M and A next to each other. So F is equal to mass times acceleration. Remember, we multiply because these two variables are next to each other in our triangle. So in order to solve for force, we have to be given mass in kilograms and acceleration in meters per second squared. So I want to point something out. We've talked about how the Newton stands for kilograms times meters per second squared. This is where that comes from. So the unit for force is the Newton, the unit for mass is kilogram, and the unit for acceleration is meters per second squared. So they took this really long, what we call a derived unit, and shortened it into the Newton in honor of Isaac Newton. If we try to solve for acceleration, we'd cover up A, and we'd be left with force over mass, so force divided by mass. We'd have to be given force in newtons and mass in kilograms. If we need to solve for mass, we'd cover up M on our formula triangle. So M is equal to force over acceleration. So force divided by acceleration. So in order to solve for mass, we have to be given force in newtons and acceleration in meters per second squared. Now turn the page over to the guided practice problems. So as usual with any word problem we do, we're going to read it out loud first, and then we're going to mark it up later. So the first problem says, how much force is needed to accelerate a truck with a mass of 2,000 kilograms at a rate of 3 meters per second squared? So when I read it again, I'm solving for force, so I'm going to circle it, and force is the letter F. I have a mass of 200 kilograms and an acceleration rate of 3 meters per second. Since I'm solving for force, F is equal to M times A. I identified M as 2,000 kilograms and acceleration as 3 meters per second squared. So 2,000 times 3 is 6,000, and because I'm solving for force, my unit is the Newton, and that's it. If you put kilogram meters per second squared, that's right, but the easiest way is just to say Newton for force. The second problem asks, what is the mass of an object that requires 15 newtons of force to accelerate it at a rate of 1.5 meters per second squared? After reading the problem again, I'm looking for mass, which has a letter M. I'm given 15 newtons of force and an acceleration rate of 1.5 meters per second squared. If I'm looking for mass, it's going to be M is equal to F divided by A. So 15 newtons is what I identified for force, divided by 1.5 meters per second squared for acceleration. 15 divided by 1.5 is equal to 10. Since I'm solving for mass, my unit's going to be the kilogram automatically. For the third problem, it says, what is the acceleration of an object that has a mass of 2 kilograms and is being pulled with a force of 18 newtons? After reading the problem again, I'm solving for acceleration, which is denoted as a letter A, given a mass of 2 kilograms and a force of 18 newtons. I'm looking for acceleration, so it'll be A is equal to F divided by M. I identified 18 newtons as my force in this problem. I'm going to divide it by the 2 kilogram, which is the mass of the object. 18 divided by 2 is 9, and because I'm solving for acceleration, my unit's automatically going to be meters per second squared. Now I want you to try questions 4 through 6 on your own, using questions 1 through 3 as a guide. If you have trouble, feel free to email me or call one of your classmates.